I'm Anil Kumar, and with the help of this video, we will understand direct or partial variation. The question here is, the table below shows the minimum volume of water needed to fight a typical fire in rooms of various sizes. So what we are given here is, uh, that is floor area in meters square, right, one column. The other one is minimum volume of water in liters. If the floor area is 20 meters square, water required is 35 liters. If the floor area is doubled, 40 meters square, then the volume required is also doubled, 70 meters square. If the floor area is 3 times, that is 60, volume required is 3 times. Do you see that? So we are given this particular data. Now the question is, explain if the above data represents direct or partial variation. Second part is, determine the minimum volume of water required to put out the fire in the room with floor area of 150 meters square. That is to say, if we have floor area of 150, you need to find the amount of water required. You can pause the video, answer the question, and then look into my suggestion. Let's begin by answering the very first question, which is, we need to explain if the above data represents direct or partial. Now, for a direct variation, what do we expect? Direct variation is like a ratio with a constant, right? So we are looking into a ratio which is constant. That is direct variation. So here we can say, what is 35 over 20? Is it equal to 70 over 40? If that is so, then it is direct variation, right? I should say direct variation. Is it okay? Now, every direct variation will have a constant. So let's find this constant of variation by dividing 35 by 20. Let us say 35 by 20 is how much? 7 over 4. Or in decimals, we could write this as 1.75. How about 70 over 40? 70 divided by 40 is equals to, in decimals, 1.75, which is also 1.75. Now, since they are equal, we know that is the value of K, the constant, right? So we can write an equation that is water required, or the volume of water is equals to constant times area, right? So that is how we could get a relation also. So we say volume of water required is constant times area, because it's a direct variation, but the area and volume are related with the constant whose value is 1.75. So I could write this as volume equals to 1.75 times area, right? So that is how this value of K helps us to find the relation. Second part is, determine the minimum volume of water required to put out fire in a room with floor area of 150 meters square. So in this case, we are given the area. Area given to us is 150 meters square, and if I substitute this, we can find volume. We need to find volume, right? So this is what we need to find. So let us substitute and calculate. So we get volume is equals to 1.75 times 150. That is equals to, let us multiply, 1.75 times 150 equals to 525 by 2, which in decimals is equals to 262.5 liters, right? So that is the unit for volume. That is how we could find it. Well, there was an alternate way also. You could use ratios. Whenever there is direct variation and we are not asked for the constant, you could use ratios to answer the question, right? So we can say this is P, let this be X, then we say X over 150 should be equal to, you could use any one of those values, we say 35 over 20. So this gets you the answer for X. You could cross multiply. X equals to 35 over 20 times 150 to get the answer. So which should be, let us calculate. 35 divided by 20 times 150 equals to, in decimals, 262.5, correct? We get exactly the same value in liters. So if we are looking for direct variation, there are two ways to solve it. One is using ratios, the other one is find the constant of proportionality, right? So that is K. So K is called constant of proportionality. So find the constant of proportionality, make up your formula and then calculate. The other way is use ratios and calculate, correct? That is how you could solve an application question on direct variation. I hope that helps. Thank you and all the best.